In this last section of chapter 6, we are going to learn about the present and future value of a continuous income stream. So when an income stream flows into an investment, the investment grows because of the continuous flows of the money and because also of the interest compounded on the money invested. Okay, so we know that we need two things in this case. A function defining the flow of money. So we have the flowing of the money into the system. And a function defining a function multiplier. Okay, so the first case we will discuss about the discrete income stream. Now I let the present value to be the notation PV and the future value to be FV. If the interest is compounded n times a year at an annual rate R for T years, then the future value is equal to the present value multiply 1 plus R over N together to the power of NT. So N is the number of the compoundings per year. So for example, the interest may be compounded quarterly, so N would be 4 times a year, or twice a year, so N would be 2 times a year. And R is the annual rate in decimal value, and T is the number of the years. So future value equal present value multiplied by 1 plus R over N to the NT power. Now, if the interest is compounded continuously, then we have the future value equal the present value multiplied by e to the power of RT. So these are the two formulas that we saw from chapter 5. Sorry, it's from chapter 1. Section 1.5. Okay, so for example, we have one problem here. You need $10,000 in your account 3 years from now. That means 10,000 is your future value in 3 years. And the interest rate is 8% per year, compounded continuously. How much should you deposit now? That means they ask you how much is for the present value, given the future value $10,000, and in 3 years, and the annual rate is 8% per year, compounded continuously. So from the last discussion, we know that if the interest is compounded continuously, we have this formula. So we know that we have to use this formula: FV equal PV e to the RT. R is the annual rate. In this case, it's 8%. So 8% in decimal is 0.08. And now we are just looking for the present value, PV. So to find the present value, we divide both sides by the term e to the RT. Okay? And PV is equal to FV divided by e to the RT. And you can bring e to the RT to the numerator. All you do now, you changing the sign to the minus. This is the exponential rule. And now we have everything. We have future value $10,000 here. We have the rate 0.08, and we have T to be 3 years. So all you need to do now is you plug in these values into a calculator, and you should get the present value should be around $7,866. So this is the amount of money that you should put in to the account in order for it to roll up to $10,000 in 3 years. So that is the discrete income stream. That means we only have one-time payment, one time for the present value. So we introduced the present and future value in a single payment in the last discussion. Now we want to calculate the present and the future value of a continuous stream of payments. That means a lot of payments are going into the account continuously. So we let the function s of t to be the flow rate, the flow of money, dollar per year. Okay, the unit is dollar per year, and we let t to be the years from the present. So first thing is we need to find the present value of a continuous income stream over a period of m years. So let's say we have the year of 0 up to the year of m, and we can divide that into the sub-intervals of n. So t0, t1, t2, t3, t4 up to tn. So we have the same amount of interval n, and each interval we have one single payment. Okay, so delta t is the m divided by the number of the n sub-interval, and we assume that over each time interval we have one payment is made. Okay, so from t0 to t1 we have one payment, from t1 to t2 we have another payment, and so on. And r is compounded continuously. That means over the year of 0 to m we have a lot of t1, t2, t3, t4 up to tn payments, because we have the flow of money, dollar per year. We have a lot of payments. It's not a single payment as you saw from the last discussion. If you are running a large company, then the money comes inside your company like every hour, every minute, every second. So we have a lot of incoming payments, and we define s of t to be the number of the dollar per year, the flow rate of the money. So each interval we have a single payment, and this represents for the overall payments of all the value that we get from 0 to m years. Now we know that the present value is equal to the future value multiplied by e to the minus rt. We got this formula from the last example here, right here. So we still use this formula to find the present value of all the interval. So we can find the present value of the total money deposits into the account, because we have a lot of payments from year 0 to year m. We need to find all the present value of those payments. So we let the income stream at the time as t1 e to the minus rt1, okay, rt1 multiplied by delta t plus the add of t2 e to the minus rt2 delta t, and so on up to tn. And this is the Riemann summation formula. And if the delta t is approaching to 0, then we have the limit of n approaching to infinity, or the present value of the income stream of payments is just the interval of 0 to m. M is the year at the end, and s of t is the function of the flow rate of money, and e to the minus rt dt. So this is the present value of all the payments. Once you get the present value, you can use the future value formula. Future value equal present value e to the rt. This is the same formula as you saw earlier. The same formula right here. Future value equal present value e to the rt. So once you get the present value of all the payments, we can find the future value equal present value e to the rt. Now in this case, your t is m years, so rm. So rm is right here, and present value is this whole expression right here. So your future value of the continuous income stream is e to the rm, because we have e to the rt and t is m right here, and this is the same factor, and present value is this whole interval right here. So this is the future value formula of the continuous income stream. Okay, let's have one example to talk about that. We have an investor, and this person is investing 3.3 million a year in an account returning 9.4% APR. Assuming a continuous income stream, this is the keyword, continuous income stream. This is not a discrete value. This is the continuous income stream. And continuous compounding of interest. How much will this investment be worth 10 years from now? That means they are looking for 10 years from now. How much do we get? That is, they are asking for the future value. So from the question, you know that we are looking for future value. And in this case, we are looking for future value of a continuous income stream, which is this formula. This is the future value of the continuous income stream. And we know that the APR 9.4%. That is the rate, the annual rate, which is 0.094 in decimal. We know that we are looking for 10 years from now, so M is 10. And we also have the S of T, 3.3 million a year. This is the continuous income stream, 3.3 million of dollars per year. So S of T, this is the flow rate of money, 3.3. Now the future value is e to the rm, the interval from 0 to m, S of T, e to the rt, dt. We got everything. We got R here. M is 10 year. The interval from 0 to 10. S of T is 3.3. E to the minus R is 0.094. And T dt. And using the calculator, you can find the future value equal to 54.8 million. So we are using this formula when we are dealing with the continuous income stream of money. The last example for this section. At what constant continuous rate must money be deposited into an account if the account contains $20 in 5 years, and the account earns 6% interest compounded continuously? So we know that in 5 years we have this much money. So this is the future value, $20,000 in 5 years. We got M, the big M is 5 years. 6%, this is the annual rate, which is 0.06. Now they ask you for at what constant continuous rate. They ask you for the continuous rate, the flow of money, S of T. They ask you for S of T in the formula here. So we are using the same formula. Future value equal e to the rm, the interval from 0 to m, S of T, e to the minus rt dt. They are looking for at what constant continuous rate, that is the flow rate of money. They ask you for the S of T value. Okay, and we assume that S of T is a constant because they said that at what constant. Constant is a single number. Okay, so because S of T is a constant, I can pull it outside of the interval. Any constant, we bring it outside of the interval. So e to the rm, S, bring it outside. And then we have the interval from 0 to m, still e to the minus rt dt. We are looking for the S, the continuous rate of money. So we are looking for the S value. Looking for S here. And to find the S value, I take FV, the future value, I divide both sides by e to the rm and the integral, so that I can isolate the s by itself. So FV divided by this term together with this term. Okay. Now the future value, we are given that with $20,000. E to the rm, r is 0.06, m is 5. The integral from 0 to m, e to the minus 0.06 t dt. We are solving for s because we are looking for at what constant continuous rate. This is the s value. And if you use the calculator, you can find the integral, and we can multiply that with this factor and take 20,000 divided by everything. So we got about $3,429 per year. So this is the money, the flow of money flowing into the account every year in 5 years, because m is 5. So $3,429 is the amount of the continuous rate must the money be deposited into an account. So that is the end of this section and the end of section 6.5.